In these examples, we will be finding the inverse Laplace transforms. In other words, given big F of S, we interpret this as being a transform, the Laplace transform of some function f of t. So let's say we have f of s equals 2s minus 1 over s squared minus 4s plus 6. Now, the first thing I would notice is that the denominator is an irreducible quadratic function. The numerator is already some linear function, so partial fraction decomposition is not going to help at this point. But what we'll do is, rewrite the denominator as s minus 2, the quantity squared, plus 2. We just complete the square. So far it's just been some algebra. We're going to do some more algebra. In order for us to do any work here, I need to get this s in the numerator in terms of s minus 2, because I need whatever this thing here is being squared, I need that same expression in the numerator. In order to make use of our table of Laplace transforms. So it's the table of Laplace transforms along with operational properties. Okay, realize that in place of s, we have s plus 2. So what we're going to have is this property right here. We're going to make use of. So we have 2 times s minus 2. So that gives me 2s minus 4. Originally we had a minus 1, so this is going to be a plus 3 over s minus 2 squared plus 2. Now you have to remember your table. See, this denominator tells you we're going to have sine and cosine. So what's happening is this 2 is a squared, so a is actually going to be the square root of 2. And again, for this first term, in place of s, we put s minus 2 for this to fit. It has to fit this form. Okay, so in place of s, I have s minus 2. I have to have that in the numerator as well. So I think we can just write down the answer. F of t is 2 e to the 2t times cosine of the square root of 2 times t. A is the square root of 2 in this case, plus 3 over the square root of 2. Notice that we would expect an a to be here. A is the square root of 2, but we don't, so we divide by the square root of 2. Of course, we have the constant of 3. We're using the linearity property of the inverse Laplace transform, so we have 3 over the square root of 2 times e to the 2t times sine of the square root of 2 times t. So it's actually very simple. We made use of these two entries in our table, and we used this operational property. Okay, replacing s with s minus a corresponds to multiplying by e to the at.